Welcome back. We're going to talk about lesson 15. The good news is there's only 3 more lessons. We've got 15, 16, and 17 to go. Lesson 15 concerns equal spread 45-degree offsets. So the objectives for this lesson are to find the position of elbows at the beginning of a parallel offset, compare the length of travel of 45-degree parallel offsets, and find the position of elbows at the end of a 45-degree offset. So we're talking about 45-degree parallel offsets, which look something like this. What's important about the 2 offsets as they run parallel to each other is we want to make sure we keep the distance between the offsets the same throughout the whole run. So this perpendicular distance on the pipes, as well as this perpendicular distance and this one, have to be the same as we run throughout, and we'll call that distance between the pipes dimension A. You'll also notice that to run this correctly and keep the distance the same distance apart throughout the run, then one pipe will have to be a certain length longer than the other pipe before the offset begins. We're going to call that length the difference between the 2 pipes before the offset, length C. You'll also notice that that will have to happen after the offset. Because of the geometry of how it works and the symmetry that's working here, that distance will be that same distance C as it was before the offset. We also have to think about the travel of the 2 pipes across the offset. So you'll notice that from this elbow to this elbow will be the same distance on the other pipe. So the travel is the same also. Good. Let's take a closer look at the geometry of what's going on here. You'll notice that that distance C, which was the difference between one pipe and the other before the offset, will form a right triangle with the elbows of the offset. So we're going to use our information about right triangles once again to figure out that distance C. A, the distance between the pipes, will be the length of one leg, and C will be the length of the other leg. We need to know something about the angles in that triangle to be able to calculate the values of the sides. So what we're talking about here is a 45-degree offset, so we know that this angle is definitely 45 degrees. Keep in mind that the angle from here all the way to here is 180 degrees. That's like when you do a 180, when you turn around and you do a 180, so that's going to be 180 degrees. Now that's all the way across. So to find the distance of this angle, or the value of that angle, we need to subtract 45 degrees from 180. So let's do that. That gives us 135 degrees. So that angle there is 135 degrees, and this side splits that angle exactly in 2. So we're going to take 135 and divide that by 2, which will give us 67.5 degrees. So I know that this angle here is 67.5. Good. I also know that all the angles in a triangle add up to 180. This one's 90 degrees because it's a right angle. And we still want to find this angle here. So there's 180 degrees total in the triangle. And to find out what we have left for this angle, we're going to subtract the 90 and subtract the 67.5. So 180 minus 90 would be 90 degrees, minus 67.5 gives us 22.5 degrees, which is nice because we know a lot about 22.5-degree triangles already. That's one of the angles that's in our triangle multiplier table, so that'll make that easy. Remember that you don't have to do this calculation every time because we're just going to be doing 45-degree offsets. So you don't have to worry about calculating this every time. Every time we're going to be doing a parallel offset, the angle is going to be our nice 22.5 degrees that we've done before. All right. So what we're going to be doing now is if you're given the distance between the pipes, which remember was A, we're going to be able to find C. So if you think about this as one of those triangles we had before, the travel would actually be this angled one here, and these two would be the advance and the set relatively. Now, we're not talking about the travel of the actual offset now. We're imagining that this was the travel, and that this is the advance, and that this is the set, because we want that relationship between the three sides. So A in that case would be the advance of the offset. And it's going to be a 22.5 degree offset. And C is the set of the offset. Okay? So if A is the advance and C is the set, we know from the table that to find the set, if you're given the advance, you multiply by 0.414. Good. So we're going to use that formula repeatedly in this section to find the distance that one pipe has to be longer than the other. Maybe we've forgotten that, so let me go over that one more time. Remember that A is the distance between the pipes, and C is the distance that one pipe will be longer than the other pipe. So if you're given A, what this formula says is that if you know A, the distance between the pipes, you multiply by 0.414 to find C. Good. Now we're going to use that formula over and over again in this section to find the length C. So here's an example. We're given that two parallel pipes are 30 inches apart. And to make a 45-degree offset, how much longer is one pipe going to be than the other? And we're going to round that calculation to the nearest 16th of an inch. Now keep in mind these are parallel offsets, so we want to keep that 30 inches constant throughout the transition. So we know our formula is C equals A times 0.414. And we know that A is 30 inches. So we'll say that that's equal to 30 inches times 0.414. And that gives you 12.42 inches. Now we're going to round that, the decimal part, to the nearest 16th. So 0.42 times 16 would be 6.72. We have to round that off, and that rounds to 7. So the value for C will be 12 inches and 7/16 of an inch. Good. So we use that formula, C equals A times 0.414, to find the distance that one pipe has to be longer than the other before the offset. The next thing you'd want to calculate is how long this pipe has to be so you can actually do the travel of that offset. So we need to find that travel. In order to find that travel, we need to know how much one pipe has been offset. This is a distance that we haven't talked about yet. We've talked about how much longer one pipe has to be than the other, but we haven't talked about how much of a difference there's going to be before the run and after the run of each of the pipes. We're going to call that dimension E. So this is going to be a 45-degree triangle, and you can think of E as the set of that offset. So we're given the set, and we need to find the travel. And from that triangle multiplier table, you'll see that if you multiply the set by 1.414, you'll get the travel. So we're going to use this formula to find the travel of the pipe. So to summarize what we just went over, if you want to start before the offset and find how much longer one pipe needs to be before the other, you're going to multiply A times 0.414. And remember that A is the center-to-center distance between the pipes. To find the travel of both pipes, that's going to be equal to the offset of the pipes times 1.414. And after the offset, one pipe must be the same distance longer than the other as it was before the offset, so it's the same formula, A times 0.414. Good, let's do an example. So say we have 2-inch pipes that are run parallel on 16-inch centers and need to be offset by 20 inches using a 45-degree offset. So what we've got is two pipes that we need to run parallel to each other. And they say that the pipes are on 16-inch centers, which means they're 16 inches apart. And they need to be offset by 20 inches. So it's important to know which one of those values, the 16 or the 20, are the A value or the E value that we were talking about. So 16 inches is the distance between the pipes, and that's A. And 20 inches is the actual offset, and that's E. OK. So let's go through this calculation. So there's three things that we're going to need to find in this example. First, we have to find out how much longer one pipe will be than the other. We have to find the center-to-center travel of the pipe. And then we have to subtract the takeout to actually find the end-to-end travel. So first, let's find out how much longer one pipe is than the other. So we know that C is that distance, and A is the distance between the pipes. And we're going to multiply that by 0.414. A, in this case, the distance between the pipes is 16 inches. So we're going to multiply 16 times 0.414, which comes out to be 6.624 inches. Can't leave the 0.624, so we'll round that to the nearest eighth this time. Multiplying by 8, that gives us 4.992, which is really close to 5. So what we've got is 6 5/8 inches. Good. So that's the distance that one pipe must be longer than the other pipe before the offset. Now let's find the center-to-center travel. The travel should equal the offset times 1.414. The offset in this case is 20 inches. So multiply that by 1.414, and you'll get 28.28 inches. Changing the decimal part to the closest eighth, we'll multiply it by 8, which gives us something close to 2. So we've got 28 2/8 inches. So we found the center-to-center travel. Now we need to find the end-to-end travel, subtracting the takeout from both fittings on each end of the pipe. So we had 28 2/8 inches, and we need to subtract 1 inch. Now that 1 inch is coming from the cast iron fittings table for a 45-degree offset with 2-inch pipes. That gives us 26 2/8 inches. So to summarize what we did, we can now find the position of elbows before an offset. We can find the travel of the offset, and we can find the position of the elbows after the offset. That's all the material for lesson 15. Good luck on that assignment. And again, I'll see you in lesson 16.